I'm Paul Phillips. I'm on the advisory board of LoopMe. My background is I've probably spent 20 years in large data problems. I started in a company called Urban Science, and there was a great competition that was put online in the late 90s called the KDD Cup. And one of the nice things about that competition was it was the very first time that a large commercial data set had been put online. And Urban Science actually had a very good team that won that competition. That was a very exciting point for me because it was the first time that actually a piece of software had beaten PhD statisticians, and that really fired me up. After that, I set up a company called Touch Clarity, thinking, what could I do with some technology that was completely automated? So what could we do in the area of machine learning or targeted marketing that we just couldn't have done before? And one of the interesting opportunities was taking web behavior and targeting different content at very high scale and high speed, targeting the right content to the right person. And actually we built a company that was very successful and became the best company in the world at doing that. It was acquired by Omniture. And after that, I looked at a bigger picture of how we could apply data on a more connected scale and bigger scale for customer types of problems, customer behavior problems, and started a company called Causata, which ran for 4 years, and I'm very happy to say was sold last year to an Israeli company. So I've been in big data for 15 years, thoroughly enjoyed, and very excited by what it offers. Yes, so I've been brought on as a strategic advisor in the area of data, and my mission here is to really understand the ad serving context. And the mission is, can we put the right ad in front of the right person at the right moment, such that we maximize the engagement to the individual and therefore also maximize the revenue from advertising. And we're in this wonderful, very data-rich environment where for every single ad serve, we know an awful lot, a piece of information about that serve context. And so there's an opportunity here to learn what are the right contexts that cause people to be engaged, enable us to choose what is the thing that we should serve. So my mission here is, can we apply big data, machine learning thinking to the LoopMe problem and deliver greater engagement and greater returns for the company? One of the very nice things about this big data and this machine learning discipline is it is a highly accountable activity. If it's well set up, everything we do, we're measuring against control groups. So we know exactly what incremental returns that we're delivering, both from the customer perspective, so how much better are the things that we're putting in front of those end users? Is that content more engaging? And if so, how much more engaging by being clever? And in terms of revenues that we deliver to the advertiser, the same thing we can measure very precisely. So I'd go, what is the most important thing? It's honestly just measuring the best machine learning or technology is the one that is delivering the greatest return. Of course, there's a lot of technology behind it, but as a short answer, that would be it. There have been 2 or 3 very big changes over the last few years that honestly make things that were just not possible 10 years ago possible today. So, a few of those things would be obviously, CPU processing power is enormously greater than it was. We have that Moore's law effect going on. Second thing is the cost of storing data has probably gone down by maybe 200 times over the last 10 years. So data volumes that we thought were huge and nearly impossible and unwieldy to use 10 years ago today, could be handled even on a desktop machine. Other things are our ability to apply new mathematical techniques. Now we have elastic infrastructure out there like Amazon Web Services. If we wanted to test something on a large scale, even 5 years ago, we would have had to go out there and buy a couple of hundred machines to try and do it at scale. That's a very expensive outlay. One of the very nice things today is we can set up our system. If we want to run a test with 200 machines, we can just configure those machines on Amazon Web Services, use them for the time we want to run the test, and then take them down. So it's extremely cost effective. We have enormous processing power. And actually, in terms of the mathematics as well, surprising to people who are not in the space, the mathematics has changed very largely over the last 10 years. We've moved from a very offline, static analysis thinking to one that is very dynamic now. It's learning in real time, managing what we call exploration and exploitation, that balance in real time. It's doing reinforcement learning to understand what are the long-term benefits of taking an immediate action and not just driving the next click. What's really going to deliver customer value over the longer term? So a lot of those mathematical methods as well have advanced considerably. So it's really a combination of those things. And we're in a very different place today than from clearly how we were even 5 years ago. It's more of a strategic asset today than it ever was. If you consider just the scale of advertising and the fact that we're moving on to mobile handsets and the variations of types of advertising media we have, the variation of the types of contexts that we're serving advertisements into. So the amount of data that we have, it's just huge. And if you look at the ability of a human to make judgments about what advertisement might work in a certain situation, you take into account the very rapid changes that take place in the marketplace. The only way to keep up with those things today and understand what is working in what particular context is to use machine learning. And the types of volumes of data that we're talking about can be, we're probably talking about, petabytes per year in the case of very large advertisers, and we absolutely expect LoopMe to be there maybe in just a year. So we have to have that underlying technology. We can't do it with humans.